Welcome back to another episode of Math in the Bubble with your host, Mr. Daly. Today, on episode 9, we're going to be looking at surface area of a bunch of um, regular shapes. Um, so, without further ado, we'll get straight into the easiest 3D solid of all, the rectangular prism. So, um, surface area is like doing area but multiple times, and you got to think about all the um, sides that make up your shape. So with a rectangular prism, there's this side one on the front, but then there's also that same side on the back. So um, when we do up a surface area problem, I use SA for surface area, and then I'll probably just make I usually just make a little um, equation that lays out all the sides. So we're going to have 2 times side number 1, and then we're going to add 2 times, we'll call this side 2, and 2 times side 3. So there's going to be a top and bottom, and a side, a left side and a right side, and those will be the same area because we're dealing with a rectangle. Okay, so um, now we just basically sub in our dimensions. So we've got, for number 1, we've got 2 meters times 3 meters. I might do it like this, plus 2 times 5 meters by 2 meters, 5 meters by 2 meters, plus um, we got 3 meters by 5 meters. 2 times 3 meters by 5 meters. Okay, so 2 times 2 times 3 is 12, plus 2 times 5 is 10, times 2 is 20, 2 times 3 is 6, times 5 is 30. We add those all up and we're going to get 62 meters squared. Meters squared, because surface area is area. Areas are measured in square units. Okay, moving on to our cylinder. So for our cylinder, we have got this side number 1 here. I might just bump that up. So the surface area is going to equal 2 times side 1, 2 times 1, and then the other side is this I like to put a line down the middle, because what we're going to do is we're going to peel away that around the cylinder. So that's going to be side 2, and that goes all the way around, and so it comes around here, comes back up, finishes on the other side. So plus side 2. So another thing you could do is draw a little picture. So that is going to be 2 circles plus a really long rectangle that gets wrapped around. Um, so, and also if you draw a little picture, you can think what you need to work out. Well, this when we unroll the cylinder, think about it on at this end. It is going all the way around the length of the circle, so that distance there is the circumference, and then this distance this way is 15 centimeters. Okay, so our circumference is equal to 2 pi r. So what we want to know is, and our circles are, there's 2 times pi r squared. So there's pi r squared is one circle, so we got 2 times pi r squared. So our surface area is going to equal 2 pi r squared plus, well, we should give this a name, we'll call this L. So plus the circumference times L, 2 pi r L. So circumference of the circle times by the length of the can. Alright, so 10 centimeters is our diameter, so our radius equals 5 centimeters. So if we put that into our formula, we're going to get 2 pi 5 squared plus 2 pi times 5 times 15. Alright, I'm just going to plot that over the picture there, so it's in the frame. 2 times pi times 5 squared for the 2 circles, plus 2 times pi times 5 times 15, 200 pi, or 628.3. We're dealing in centimeters, so we got centimeters squared. Sorry about wasting a colossal amount of your time then. I'm going to move on to a sphere. And a sphere is a nice question because there's a direct formula to work it out. There probably was one for that pyramid. Just the fact that I got a nice round number like 10, which was basically what I started with, makes me think there was another way to get to that answer. But oh well. Alright, so a sphere, just surface area of a sphere is quite simple. You just have this formula 4 times pi times r squared. So if we had this ball, let's say 200 centimeters. It's a big exercise ball. How much material is involved? So the radius equals 100 centimeters. This is a huge, that would be a huge sword ball actually. So the surface area equals 4 times pi times 100 squared. 125,700. 4 significant figures, centimeters squared. All right. And also to jog your guys' memories, if we're going centimeters squared into meters squared, then we want to think, okay, 1 meter squared, 100 by 100 equals 1 meter squared. So 10,000 centimeters squared equals 1 meter squared. So to go from 10,000 to 1, we would divide by 10,000. So if we use our current answer, divide by 10,000, 12.57 meters squared. Alright, for this one I might use a 3, 4, 5 triangle. 3, 4, 5. Well, yeah, it was if you think about it, this is a pretty big ball. A ball that's 2 meters in diameter. That's the height of a doorway. So that spherically probably would be about that. Yeah, this would be your social distancing ball. So you could probably stand inside that. This could be the future. uh, where is the Indy the boy? That's the real question. Haven't seen him on yet. Okay. Um, yeah, that was last year, wasn't it? Okay. So a cone. So when you have a cone, you you have this sort of problem when you unfold it. So if we look at our cone right here, um, what can we take from it? Well, we know this distance here is 3, and then this distance here is 5. So we don't actually use the 4 at all, because think about it, the 4 is like a vertical line inside the cone. It doesn't actually touch any of the sides. So um, the height of the cone is used to figure out the volume of the pyramid of the cone, but not actually use to work out the surface area. Alright, so the other thing is that this distance here, so we'll call that we'll just make this a full circle. This distance x is the same as the circumference, because the cone has to go, this has to wrap all the way around the cone. So x equals c. Now the thing we need to figure out is how big of an angle does this go through? And that is quite a problem. And to do that, we need to work out the circumference, because the circumference is x, and we also want to work out this full circle. So I'll just go small circle is going to be pi times 3 squared, and the big circle is going to be pi times 5 squared. Because area of a circle is pi r squared. Hold up. No, I don't want to be using area. I want to be using circumference. So scratch that. Let's go. There's going to be a lot of editing in this video, I can tell. 2 pi r. Let's just do that again. Two pi times 3, 2 pi times 5. Eighteen point 85. And we want to delete that and make it by 5. 31.46. Okay, so 31.46 is the whole way around the circle, and 18.85, that is x distance around the circle. And we know there's 360 degrees in a circle, so these two are going to make a proportion. If we make that a fraction, 18.85 over 31.46, and then we times it by 360, that'll get us our theta. 18.85 divided by 31.46 times 360 gives us a theta of 215.7 degrees. Alright, now we can start doing area, because to work out the area of the big circle, then we just want to go pi times 5 squared. So that would be the area without that proportion cut out. So we want to multiply that by our proportion of the 360 degrees. So this is like the fraction of the circle. So 215 degrees out of 360 degrees. It's basically a big fraction. That's our fraction of the circle, right? So times 215.7 divided by 360 47.06. What are we going to be? What are our units? We'll just do meters. So meters squared, because we're dealing with the area, and our small circle, we just use a full circle for that, so no proportion. So that'll be pi 3 squared. I already worked this out earlier by mistake. 28.27 meters squared. So we need to add those two areas, because we've got those two parts of the shape. So that equals 75.33 meters squared. Oi, 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 oi.